In the last video, we looked at the scale factor for similar solids. Now we're going to use this idea to solve problems to find volume of different solids. So I know you remember, hopefully from before, that if we call the scale factor A over B, then we know that the ratio of perimeters is also A over B. Okay? And then we found out that the ratio of areas, we just took A and squared it, took B and squared it, and this was the ratio of the areas. Finally, what we're using today is the ratio of volumes. And if you take this idea of area would be area A squared over B squared, then for volumes it should be A cubed over B cubed. Okay? So, here are two cans of peaches. We have the surface areas and we have the volumes. We know that the scale factor is 87 to 100. We want to find the scale factor and volume for the larger can when the scale factor and volume for the smaller can are here. Okay? So our scale factor is 87 over 100. If we want to figure out the ratio of the areas, we would use that to find the surface area. So if we take 87 and we square it, so let's see, ratio of areas, that's going to be 87 squared over 100 squared, and that's going to equal 7,569 over 10,000. Okay? So what we can do now is we can say, since 1 is the smaller one, we can say 7,569 over 10,000 is going to be equal to surface area for 1, which is here, over the surface area for number 2. So in this case it would be 7,569 over 10,000, and the surface area for the smaller one is 51.84, and we'll just call this surface area for number 2. So if we cross multiply, we get 7,569 times S2. I guess that shouldn't be that big. S2. Okay. And the other side, we would move this over 4 decimal places. So it would be 51,840 if I moved it over. Whoops, sorry. That's incorrect. 1, 2, 3, 4. So it would be 518,400. We're going to divide these two. Excuse me. And we're going to go ahead and do 518,400 divided by 7,569. And we end up with a surface area for number 2 of 68.49 square inches. Okay? For the volume, the first thing we need to do, again, our surface area was 87 over 100. We want to find the ratio of volumes. So we're going to say 87 cubed over 100 cubed. 87 cubed ends up being 658,503, and on the bottom 100 cubed ends up being 1,000,000. So now we know that 658,503 over 1,000,000 is going to equal the, I'm sorry, not the surface area this time, the volume for 1 over the volume for number 2. So that gives us 600 and, sorry, did it again. 658,503 over a million. And the volume for 1 was 28.27. And the bottom one we would just say not surface area. Keep wanting to do that. Volume for number 2. Cross multiplying, we get 658,503 times the volume for 2. And now we're going to add 6 to that, so I guess 4 more. 1, 2, 3, 4. That gives us 28,270,000. We're going to divide both sides by that 658,503. So those cancel and those cancel. We're left with the volume for number 2. I'm going to go ahead and punch this in. And we get approximately 42.93 cubic inches. So there's our answer, 68.49, 42.93. So we write the two proportion surface areas, and then it would be a squared over b squared. Remember, this side was 58.4, this is 87 squared over 100 squared. For volumes, we do a cubed over b cubed. The volume for 1 was 28.27, and this would be 87 cubed over 100 cubed. And then we just need to solve these. The first one again would be 68.49. The second one, 42.93. Okay? So there we get our answers. Now we're going to look at the scale factor. And remember, the important part of this problem is we're doing P to Q. So it's this to this when we do it. We know that the volume for P is 1,000 cubic inches. For Q, it's 216 cubic inches. So we would say that the ratio of volumes is for P to Q would be 1,000 over 216. And remember that this is A cubed over B cubed. So what we want to do is go ahead and do the cube root of this, because that is a perfect cube, and do the cube root of this. Those are both perfect cubes. This would give us A over B, and A over B happens to be our scale factor. So we would say the cube root of 1,000 and the cube root of 216. Cube root of 1,000 ends up being 10. Cube root of 216 ends up being 6. And we can reduce this. These are both divisible by 5. I'm sorry, by 2. So it gives us 5 to 3. We could have also, by the way, simplified here first. It doesn't matter. I just recognized those were perfect cubes, so I went and did it first. They may do it slightly different, but it works either way. So again, we know A cubed over B cubed is 1,000 over 216. We find the cube roots, we get 10 over 6. We reduce, we get 5 over 3. Our scale factor is 5 to 3. Okay. Again, remember, it said P to Q, so you'd write 5 to 3. If you'd written 3 to 5, it would be wrong. Here's another type of problem. It says a store sells balls of yarn in 2 different sizes. The diameter of the larger ball is twice the diameter of the smaller ball. And the balls of yarn cost $7.50 and $1.50. Which one's the better buy? Well, we would want to look at the volume for both of these. So we know that, let's say, volume for big and volume for small. Okay. In this case, it would be 4/3 pi r cubed, and this would be the big radius, and here we would have 4/3 pi r, let's say SML there, SMALL cubed. Okay, let me try that one more time. SMALL. Alright, so it says the diameter here is twice the diameter of the smaller ball, so that means that the radius would also be twice as big. So if we wanted to, we could say this was r and this would be 2r. So let's do that. Let's go ahead and say for this one it would be 2r. Or I'm sorry, yes, cubed. So if we do that, this would actually be 4/3 pi, and this would end up equaling 8r cubed. I guess we don't, yeah, we do. So my final here would be 32 pi r cubed, 32/3. If we want to write the ratio, what we do is write the ratio of the volumes, so volume big over volume small, and that would give me 32/3 pi r cubed, and over here it would be 4/3 pi r cubed. The r cubes cancel, the pi's cancel, and actually the 3's cancel. So what we can do is look at it and say it's 8-to-1. So in other words, by doubling the radius, we've made it 8 times more. The volume is 8 times bigger. Now, if we look at the cost for big over cost for small. In this case, we would have 750 over 150. And those, if we reduce them, that's really what, 7.5 over 1.5, and that goes in 5 times. So it would be 5-to-1. Okay? So if you look at it, we're paying 5 times more, but we're getting 8 times more than we normally would. So since the cost is only 5 times more, and we're getting 8 times more than we would the other piece of yarn, then we would say the big ball of yarn would be the better buy, which is usually the case. It's sort of like a bulk kind of thing. They may have done it slightly different, but let's take a look at what they did. We'll go through it slowly. We want to compare the ratios using the diameters. And, oh, yeah, I could have done it that way too. Duh, that was an easier way. 8-to-1 is the volume of the ratio of the volumes. So the ratio of the costs would be 750 to 150, which ends up being 5-to-1. And if we compare the two ratios, if the ratios were the same, neither would be the better buy. Comparing the smaller to the larger one, we can see the price increase is less than the volume increase, so we'll get more yarn for your dollar with the larger ball of yarn. Again, we're paying 5 times more, but we're getting 8 times more than we would if we bought the small ball of yarn. So I apologize, I made that a little bit more complicated than it needed to be. All we really needed to do was compare the diameters or the radiuses. Okay, here's another one. We've got the surface areas for these two, and we want to find the scale factor. Then we want to find the edge length and use that to find use the scale factor to find the volume. All right, so let's see. First of all, let's do a ratio of areas. And again, we're doing C to D, so it's this to this. In this case, it would be 54 over 150. And those are both divisible by 2 for sure. That would give me 27. Divide that by 2, I get 75. Those are both divisible by 3. So we would get 9 here and 25 here. We want to know the scale factor. Well, this ratio is a squared over b squared. So if I take the square root of this and the square root of this, that's going to give me my a to b, which is what I want. So I'm going to do square root of 9 and square root of 25. We know the scale factor is therefore 3 to 5. And it says to find the edge length of C. So if we know the edge length of C, let's see. If it's a surface area, the surface area of a cube would be found by doing, there's 6 surfaces, and each of them have the same area. So to find the area of one of these surfaces, we would take 54 and divide it by 6, giving us an area of 9 square units for one surface. And if we want to know the edge length, remember this is the area of a square, so we would take the square root of it. That would give us 3 units for the edge length. So we're going to use the scale factor. Sorry. We know the edge length. Let's see, here's the scale factor. Here's the edge length. If I wanted to know the volume for C, what I do is I would take the area of the base, which is 3 squared, and multiply that times the height. It is a cube, so it's 3 as well. So the volume for C would be 3 cubed, which is 9 times 3, or 27 cubic units. Now, since we know the scale factor is 3 to 5, we want to know the ratio of the volumes. So that's going to be the same as a cubed over b cubed. That gives us 3 cubed over 5 cubed, or 27 over 125. So to find the volume of D, we would take this 27 over 125. Sorry about that. Got a lag there. And that's going to be equal to the volume for C over the volume for D. In this case, it would be 27 over 125 is equal to 27 over the volume of D. And this makes it pretty easy because we can see it's 27 and 27. So the volume of D, hopefully you can see in that case without cross multiplying, that would be 125 cubic units. Okay? So again, we write the ratio, we simplify it to get 3 to 5. No need to simplify that time. We find the edge length. We're going to take the surface area and divide by 6 to get 9. We then square root it to get our edge length. And then find the volume of D. Use the scale factor here. So the volume is 125. Okay? So I think my way was actually a little bit better. But that's okay. Alright, it says calculate a new price when neither ball... Oh, okay, calculate a new price for the larger ball so that neither ball would be a better buy than the other. Okay. Well, let's go back. So we look at this and we say, here's the price for the first one, and we want this to be 5 times more than it. Oh, I'm sorry. So that neither would be the better buy. Well, we would want this. We would want to take this and multiply it by 8 in order to make it the same price, basically, because the ratio of volumes was equal to 8 to 1. If this is 150, we would want this to be 8 times more, so we would say 8 to 1 equals 150 over x. So we want them to be the same price. We would want the new price to be 8 times 150. Oops. So that's 2. That's 3, 6, 9. I think it's $12. Should be $12. 0 carried the 4. Yeah, should be $12 then. If the bigger ball of yarn was $12, then it would be the same price. Yeah, there you go, $12. And we're done. Thanks.